the paper I'm going to present today is something that we're going to submit very soon. It's called Are Biofuel Mandates Cost Effective? So it's an analysis of transport fuel and biomass usage in a future European energy system. And that title probably says quite a lot. However, I just want to mention one thing, and that is that like by design, at least theoretically, biofuel mandates cannot be cost effective, at least not compared to a first best policy like a CO2 tax or a CO2 cap like in the EU. Sorry, I'm just going to close the door to my cat. Because mandates are a second best policy, and thus enforcing them will always be less cost effective than a CO2 tax or the like. So that's like the theoretical part of this. So the theoretical part is like then assessing the cost of using a second best in addition to a first best policy measure. The practical part is that having biofuel mandates is a pretty extensive practice, at least in the north of Europe, like in Sweden and Finland. So it might be of practical importance for policymakers to actually know how much extra they would cost. Now, this is joint work together with Marcus Millinger, Fredrik Hedenius, Göran Berndes, and they're all at Chalmers. And then also we have Elizabeth Sayen and Tom Brown at TU Berlin. And they are two people who developed the model that we have used for this. And they have also taken part in the design and writing here. But more than anyone, this work belongs to Marcus Millinger, and I think he's also here today, for which I'm very fortunate because he will be able to answer the questions that I'm not able to answer. Right. Okay, so first some background. Basically, liquid fuel demand is likely to come down because of electrification of transport and other things. But there is also likely to be a remaining demand for these fuels also in the more distant future. So we're looking at approximately 2040 and 2060. And even in 2060, there's still substantial demand, is what we assume, from mostly shipping, industry, and aviation. And there are a few carbon neutral options to fulfill that demand. One of them is biofuels. Another is electrofuels. Please ask me if you don't know what that is, but I think most people do. And a third option would be to continue to use fossil fuels, but then use negative emission technologies and store the carbon dioxide. So all those three are carbon neutral options, and all three come with potential problems. So electrofuels it's a bit uncertain what the cost for those are. To continue to use fossil fuels can be argued to be like a bad idea, propagating the path dependency of fossils that we're on and not stimulating new technology and such. And also the carbon sequestration options are quite uncertain. And there's also public resistance against that. So given this, it might be a bit unfair that we have here only looked at the effect of increasing the biofuel share in the liquid fuel mix. But anyway, that's what we've done. And part of it is probably because we have a local outlook where, at least in Sweden and also in other Northern European countries, there's let's call them a biofuel, not quite a lobby, but there are at least people who really like biofuels. And one such stakeholder is the forestry industry, who like to see their product or residuals from the forestry become something, valuable. Okay. Now, the the cons with the fuel policy, I already mentioned, it's going to be more costly, or it may also propagate a path dependency. So basically, if we do the fuel policy now, we can either stick with it, and then things are going to be more costly, and then or we can go to, say, electrofuels in the future, but then we are there with maybe a lot of infrastructure and like biofuel production facilities that cannot be used anymore. Now, however, there are also pros of fuel policy compared to only a CO2 tax or the like. And one of them is that the transport often stays more or less domestic, or at least in the EU. And then policies that are within transport is thus not as like vulnerable to international competition as other policies that for instance, industry that export a lot. And it may also contribute to technology development within fuel production. And within the EU, there are a few of these policies that are either already decided or about to be decided. For instance, the RED III suggests increasing renewable fuel shares in aviation by 63% in 2050. Part of that should be electrofuels, and part of it can be anything. Sweden has an ambitious target for 2030, and Finland also has a similar target. And for 2030, in practice, that share has to be biofuels, because the technology development within electrofuels are not going to be able to be produce that kind of amount in 2030. So the question here is then, there is a certain amount of biomass, and it can be used for multiple purposes. It can be used for transport and fuel. It can be used for heating, for electricity, potentially within BECCS, so storing the CO2, and also for industry use. And what we do here is that we increase the amount that goes to fuels and see what that does with the cost. So the research questions are, how costly are biofuel mandates? And also as a sub-question, what drives the cost increase? Now, here we have used a model called PyPSA, actually PyPSA-Eur-Sec. So it's a sector-coupled model, which means that not only electricity, but also heat and transport and industry is included in the model. It has a high spatial and temporal resolution, although the spatial resolution is not quite high as suggested by this figure, because we use the setup with 37 nodes. the model is very flexible in terms of spatial and temporal resolution, but the setup that we used has only 37 nodes. And it has a 1 hour resolution for a year. Okay, so what we did was that we ran scenarios, and the basic difference between the scenarios is that we have different mandate levels. So we run with no mandate up to 100% biofuel of the liquid fuels. And we looked at 2 approximate years. One is 2040, where we have CO2 emissions of -80%. And the other is 2060, which has a negative emission target of 5%. So there are also other assumptions that differ between these 2 years. And if you want to, you can look at the preprint if you're interested in the details. Right. And then we also looked at different scenarios with respect to biomass availability and CO2 capture availability, so storage. No, sorry, not capture, but the storage of CO2. And why do you think we chose these 2 parameters as important for our research question? Yeah, that's an ice cream.
So, Stein Erik?
Yeah, so climate change may affect the availability of biomass for fuels, and CO2 storage capacity may be limited. There's the North Sea, but maybe not so much else in Europe. Just guessing.
Yeah. Can you repeat the last sentence, Emil?
The capacity for storage of CO2 in Europe may be limited. There's the North Sea, but maybe not so much else.
Yeah, I mean, I think you are right about that. We don't know how much storage capacity there is, but so that's one reason why we chose that. And another reason is that we think a priori it might affect the results, because the amount of CO2 storage affects how much fossil fuel you can use and still use negative emissions in order to compensate for that. So it basically, the amount of storage affects one of the competing options for carbon neutral liquid fuels, namely fossil fuels plus capture and storage of CO2. So that's why we thought that might be important. And then the amount, the supply of biomass also includes the cost. So the supply curve of biomass affects the cost of making biofuels. So that was one parameter that we thought might be important. So we had 4 scenarios regarding these 2 things, obviously with a small biomass supply and a large biomass supply, and a smaller amount of storage and a larger amount of storage, and the mix of the 2. Here's one figure that shows the biomass supply. So the low biomass supply that we used here is on the left-hand side, the blue, and the high is the red one, and don't worry about the yellow, it's something else. So what we assumed is that there's a certain supply curve for the domestic biomass supply, And anything that is required above that is imported, and the import cost is much higher than the cost for the domestic supply. So those were our assumptions for input data on biomass. Okay, coming back to the model. So many things that we is part of this model is endogenous in the model. And those of you who have worked with these kinds of models, you probably know this, that the generation capacity is endogenous. So that's decided by the model, and it's greenfield and it's overnight. And also the transmission capacity, as well as the production from different facilities, storage capacity also. However, we had some assumptions that determine the exogenous demand. Electricity demand, and in electricity demand also includes the demand from transport. And there we made some assumptions regarding the share of passenger transport and road transport that is electrified. And especially for 2060, it's very high, all passenger demand and almost all heavy transport on road is electrified. But then the shipping and the aviation is, or actually shipping is partly hydrogen, and aviation is, Marcus, please correct me if I'm wrong. I think it's all liquid fuel and no hydrogen. Maybe some electrification of domestic aviation. Sorry, I'm going to have to come back with that. And there's also heat demand in the model, and then there's a liquid fuel demand. Okay. So this figure basically says that as of now in 2018, the demand for liquid fuels is about 5,500 terawatt hours, and it decreases due to our assumptions substantially for 2040 by about 30%, and for 2060 by more than 60%. So keep that in mind when we look at the biofuel mandates, because they are they're in percentage, while the total demand is substantially lower, especially for 2060. And that is because a lot of the transport sector is electrified, and there is, albeit a higher demand for aviation fuel, but there is a large share of hydrogen in marine transport. Okay, so now we come to the results. Okay, let's first look at the left-hand side of this graph. It's a bit complicated. So on the x-axis is the biofuel share. And again, this is in 2040. And the graph shows the cost increase due to the mandates. So you can see here that the cost increases for the more mandates you have, the higher cost. And that is, again, theoretically very sound. And you can see that for a 20% mandate, the increase is between something very small and about 80 billion euro. And how much is 80 billion euro? that's hard to grasp. So we tried to do an estimate on how much the transport fuel cost in 2018, and that was about 280 million. So as you can see here, for a biofuel mandate of 20%, it actually is quite a substantial increase in cost still. And one more important thing, coming back to the 4 scenarios we had regarding biomass availability and storage potential, we see that the biomass availability is important for how costly these mandates are going to be. However, the storage potential does not seem to impact costs so much. And the vertical lines here are from the sensitivity analysis, so let's not worry about them too much here. But we can still see that a 20% mandate may increase costs quite a lot. A 50% mandate does increase costs substantially by more than half than the cost for liquid fuels in 2018. Now, going to the right-hand side, we can see the results for 2060. And remember that the amount of liquid fuels is much smaller than overall. And there we can see that the cost increase is much lower. And maybe the 20% mandate, or somewhere between 20 and 50%, is what is more relevant in terms of current policy or current suggestions for policy.